gets a little bit harder because you're going to be doing 3D and that sort of thing. So the effort needs to be put into this first one. You guys have got an extra week to the degrees to get it in, which is good. So you've got about 3 or 4 weeks time. I don't accept any excuses for anyone that's saying that they're up till midnight trying to finish assignments. And please be nice to me, I'm sorry I handed in late and all that sort of carry on, because these assignments, the last one was on Moodle for 45 days, you know. And it's if I was going to give you one tip for passing everything at Unitech, get yourself a calendar this big and put it on your wall right beside where your chair is that you're doing your study, so you can turn around and you can write every single hand in on there and work out exactly how you're going to get from A to B at the end of the year. And my biggest problem when I studied was probably the same as a lot of you, because I was quite young when I was doing it, was, oh, I've got 3 hand-ins on the 20th of September, I'll start studying for them on the 19th. And that was just the way that I did it, and it just about backfired on me on many occasions. But if you plan it in little slots, by the time the 20th comes along, it's no problem at all. A little spoiler alert, my test for structures always coincides with the materials test and 2 other major hand-ins for the surveyors as well. So when you see those dates at the beginning of the year, throw them on the calendar, because the other guys are going to do theirs a bit further down the line and give you a bit of a fright. Okay. So what are we studying now? We're just about to move into the structural side of things. Unfortunately, life's not fair. If you did this with me in the first semester, we would be now having a mid-semester break and relaxing a bit more without seeing me, and we would start structures after that, which is a very logical way of doing it. Unfortunately, you're not, so we've got 3 weeks of it, and then you've got, I think, a hand-in not long after that. So we've got to kind of cram most of the structures into these next few weeks. Yeah.
So our hand-in is before the mid-semester break?
I can't remember when the hand-in is, sorry. I mean, I could answer that, and then there'd be 50 people looking at me going, like you said. But it's whatever it is. Yes. Yeah.
7th October.
Yeah. And is that in the first week of the break, or something like that? Yeah. So those that are going back home to lie on a beach in Fiji, or those that are going on holiday in Europe with their parents to France or something, you've still got to have it on the first week of the break. Okay?
Yeah, we can.
In fact, those people probably will see them again next year. All right?
Down Sunday.
I shouldn't really pick on Fiji people, because there's some lovely holidays in summer as well. And if you want to go back to Dubai or China or something like that, yep, same thing. So today I'm going to talk about concrete, and I'm going to talk about your assignment, and we're going to make that public and available to you in a few minutes, so anybody with a laptop here or whatever will see that. And you will be able to, as you walk away from your lab tonight, you'll be able to do 10 marks out of 15 on assignment 3. Okay, some of you that have a little bit of experience with materials, for example, concrete, steel, timber, whether it's building a deck at home or whatever, you're probably going to be able to take the last 5 marks a little bit further before class. Next week we do steel, and the following week we do timber. Okay. Concrete's probably the most intense, and it sort of tapers off a little bit after that. So the lab is also very important for attending this week. I'm going to go over a class example, which we will work our way through bit by bit, and you need to get your head around that. And also I'm going to show you a drawing of how I would draw or present the second class example. So you'll see how I draw it, which gives you a wee bit of an idea how to do your own drawings. Okay. You're very lucky this year in terms of the bridge that we're about to do. The abutment, the reinforcing on the abutment is very, very similar to your test. It's almost identical, so if you can get your head around the assignment, that test is going to be a lot easier than the other students in the past. In the past we've done platforms of buildings and slabs, concrete slabs on the ground, and they get to the test and it's abutment, and they're like, oh, that's quite different to what I did in the test. So this time round, if you do your own work or understand it, you'll nail the test. I can assure you of that. Speaking of the test, as I try to log in at the same time, unfortunately a number of students still haven't got their rounding correct, so I'll do that one more time. There is a different way of rounding in surveying, I believe, but this isn't surveying. This is civil and structural drawing, so I will show you how we round. Oops, hopefully we'll start with it. No, oh, again. So with the rounding, we have a number like 25.07 4932 or 25.07 5186. We take our, if the answer is 2 decimal places, we take our 2 decimal places and we interrogate the next number. So in this particular case, the top one, 4 is down, so we keep this number here. In this case, the number will change to 8. And that is rounding as I was taught in engineering. Okay? So there will be an opportunity to stuff that up again at the end of the semester. My problem is that a lot of students have, and some students ignored the 2 decimal points, unbelievably, put 3 decimal points into Moodle, and it just went, I don't want to mark that at all. Okay, so first of all, check the decimal points. Secondly, if you don't understand that, you're welcome to email me. I'll give you a whole page of examples if you want. It's not really that difficult. The other thing is the long section. There was a number of students, and I banged, you can review anybody's tape you want at all of my video, of my lectures. I definitely said that when you're calculating, do it from the left-hand side. So if you've got something over here that you're calculating in one of the boxes, you start from the left-hand side and work it out by the grade. You don't do it close to whatever the number is. I said that the numbers that I put into Moodle were calculated from here. They were not calculated from, because you could have taken any of those points along there and done it, and the 2 decimal places means you can easily be just a little bit out and Moodle will mark you wrong. The only consolation is if you end up on 48 or 9, I'll go back over those. I've got everybody's bundle of scribbles, and if I can see some marks there, I will add it on. But I don't do digital tests so that I end up having to do that for the next 3 months. Okay. Concrete. So, let's scroll with there, just about there.
Nice.
So I'm going to make the assignment available, and I'm going to make the concrete notes available. And I think probably the first thing we should do is look at the assignment. So the very first thing I notice here is the title block is A3. So don't use the title block from assignment 1, or you'll get yourself into all sorts of trouble. The second thing is I'm not giving you a drawing. Yay, you don't have to actually play with my drawing. You're starting from absolutely scratch like you did. Thirdly, you need to remember back to technical literacy, starting with the clock. What did you do when you drew the clock? You were drawing it in millimetres. Then you moved on to draw a, it was last semester, some sort of pipe inside a retaining wall type thing. Yeah. So all of those learning outcomes you need to bring forward because there'll be a number of things that we're going to be using from there. So grab your old drawings from there, have a look at them, the ground hatch, the way how you lined up all your text very nicely in the same text box. With structure, we try to do that as best as possible. With civil and survey sites, you get a little bit of a free license. You can put notes where you want, where they fit. Okay, and yeah, in my time, the surveyors and the engineers had to swap jobs and go out and get experience. The fun part was when the surveyors came into the office because they were used to scribbling notes because it was hand drawn all over their drawings. All of a sudden, things had to line up neatly, and it was not something they enjoyed doing. No different than me having to go out and run up and down hills doing cross sections. All right. So at the end of the day, I want to see the notes all lined up. I want to see your leader lines absolutely perfect. I'll do it one more time on the board. I'm getting a wee bit sick of this, but I'll do it one more time. So a leader, and I'm really hoping the diplomas have actually listened or reviewed the tapes here and done things properly. Lecturer. If you write that, do you get half a mark? If you write that, you'll make me laugh. Just before I take half the mark off. Right, so the thing that we're pointing at is in these locations. Okay, so I'm going to draw some examples of what students have done. And I'll draw the correct way to do it. Halfway between the S there and straight up. Because it's the top line. We're going down this time, so it's the right hand side. So we're going to go here and down to here. Halfway there and down to there. Halfway up here and up. And I admit there are times when, it's there, so it's a little bit trickier. But at the end of the day, that's how we do our leaders. Now, if you want to try now, Ingrid would have marked you down if you did a little leader followed by a big one, followed by a massive one, followed by a little one. By the word leader, I'm talking about the start of the leader. That should be consistently very similar. If you use Q leader, you get an opportunity to stretch it. If you use the other one, it kind of puts one about this big, which isn't correct. Easiest way to get them all the same is to copy them. This is the way I've always done it. I go copy, copy, copy. So I go copy, bang, 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 bang with my leaders. And then I just stretch the arrow bit by clicking once and moving it to the right position. And by the way, if you're pointing at my head, for example, you don't just do that. You take the arrow all the way as close as you possibly can to my head. Alright? The amount of people that, like here's your platform, and they had an arrow that stopped about there and it said platform. It could be anything. It needs to be pointing to as close as possible whatever you're pointing to as well. Now these are basic things that you would have been penalised for in technical literacy, and you probably went, doesn't matter. And you passed the course, well done, and you're sitting in my class, and you will be nailed for them big time because that shouldn't be on a professional drawing in any way whatsoever, okay? I do get comments back. Roger's a terrible marker, mean marker. What was one of the best ones I saw? Oh, brutal. That was a good one as well. A brutal marker. And then I had people would write a paragraph saying, what difference does it make the text height? I got it right. Well, if I was to show you two drawings, one by a 3-year-old and one by a very professional person drawing it, with exactly the same things on it, you know, one goes on the fridge, the other one goes out to sight. Okay, somewhere in the middle there is what I want you guys to be doing. One day you might thank me for it, sitting in an office, but anyway, the blue ones are the ones that I want, and that's the way it's got to be. Please don't do some horrible ones that I'm seeing. I have a maximum of 1 mark off for that sort of thing, and big text and all that. Most students at the most get half a mark off. The one thing that really upsets me the most is either multiple of those all over the place wrong, or the viewport, wrong scale on the viewport. That's -1 instantly. Should actually be -15. No, you never send a client a drawing that's not got the right scale on it. That's instant sacking almost. Okay, so I've given you an A3 title block and another logo, but the logo is the same. Bring it in the same way. I've also supplied 3 steel members, which you can use in your drawing. You're most welcome to copy paste them into your drawing, but you won't be using them till assignment 4. Okay, but they're there. Save them. Put them somewhere where you can use them. Steel members. Abutment reinforcing sketch. I'll get to that in a second. I think probably the first thing we should do is double click on this and see what happens. Save it and open it. Drum roll. So this is what you're going to be drawing up, if it ever shows. And you will be doing a 3D of this for 5 marks. You can put that in your sequel of this course if you want. Lecturers computer very, very slow. Is it? Yeah, it is a computer, it's not virtual. Okay, so you're allowed to ignore my weird-looking students walking across the bridge if you want. I actually pinched that from a student. It was a sort of a robot, but I've tried to make it a little more like a student. Okay, so what have we got there? The green bits, I might just turn that lights off a second. The green bits are what we call an abutment. They're kind of like an upside down T. That's the concrete bit. That's the bit that we're going to be doing the reinforcing drawing of for your first part of your assignment, looking in plan view down on it. This piece of padding here is what the beams are going to be sitting on, and the reason for that is the difference between concrete and steel, and the fact that at different times of the year they'll swell up or contract depending on the properties of the material. So that takes care of that expansion. It also provides padding. Normally we probably wouldn't do that on a footbridge, but definitely on a bridge where a car is going to go across and create some sort of weight on top of it. So we have beams on top of that, which is steel, and automatically that is saying to me that as far as the construction on site goes, you're going to need a pretty big crane and a pretty big truck. If I was doing this in real life, I probably would have split the beam in half so that we could carry it and move it a lot better. I've used columns along here. Normally we would just do beams as well, but I wanted to incorporate more steel members in there, so I've used columns. And these yellow ones here are posts. They're 200 by 200 timber posts. If you know anything about timber, we'll be doing that in 3 weeks' time. We're going to need the highest amount of tantalization on that because it's going into the water. Normal deck timber would be what we call H4 treated. We're talking about H5 here, which is, I I have heard of H6 as well, but H5 is what we're going to be using on these posts here. There will be some notes that I'm going to give you, which you'll see they go 2.5 metres into the ground. So the calculation will be from here to here. This comes down at 2 to 1. So you're going to have to draw a little bit of it up to try and work out some of your lengths of your members, because you'll be scheduling this as part of assignment 3. By scheduling, I mean each individual member will be called up and you'll put a quantity on things. With steel, it's all about weight. With timber, it's all about the length and the size of the timber. And of course, deciding on the channelization needed. So these ones here would probably be H4, and these ones here would be the H5. H4 because it's above ground, but it still needs to be treated for outdoor use. On the top here we have just a normal piece of timber, but over here we have something a bit special. We've got a plate on either side of an angle. An angle is an L-shaped steel member, and those steel members there that I've given you are this one, and the angle, but I've only given you a cross section of them, how you draw them up. I want you to use my steel members. I don't want you to go into steel books and work out the exact way to draw up these members, because you'll get a slight discrepancy, which I don't particularly feel like with marking. If you do it with mine, everything will work out quite nicely for you. I've introduced some welding here to the plate, and the plate, of course, we're going to go on and next week and talk about how we work out the holes in plates and the spacings for the holes when we draw them up. So yeah, it incorporates quite a lot. There's quite a bit in here. I'll step you through the 3D side of things. It is kind of, word of warning, it's a bit of fun. It's actually not too bad of all the classes and the things you do. You know, it's a bit like breaking concrete. That's fun, but making it's not so much fun. You guys probably didn't get to see the breaking machine there. I don't know that they just load it up with stress and it explodes. Yeah, doesn't matter. We did that with some steel when I was about your age, and we shot a bit of steel across the room and lodged it into one of the walls. So we didn't do that one again. It was like a bullet. So we're also going to be talking about how we're going to secure some of these members. So there'll be bolting in here, there'll be bolts going through here, there'll be bolts on the top of the deck, and there'll be screws on the top of the deck of some sort, and there'll also be bolts in here, there'll be screws there, and there'll be screws that screw down the decking boards. And I'll go into all the different types of screws and nuts and bolts, and you'll have to choose the type. For example, the head. Is it a rounded head, or is it one of those ones that students are going to hurt their feet on if they're in bare feet when they walk across the roof? Those sort of decisions you'll have to make. And you'll have to count them all up. That's what scheduling's all about. It's not something that is hard, it's just something that takes a wee while to do. So that's what we're drawing. The actual 2D plans, now the reason why I produced that is because students can't get their heads around the 2D drawings, but once they see this they tend to go, oh okay, that's what it's going to look like. So having said that, let's have a look and see the reaction from you guys. In terms of the supplied 2D drawings, here's the first one, and you'll notice that this is roughly what I want you to draw, except, and this is for the tape, I'm looking straight into the camera, if you draw that you will not get full marks, and I'll show you why. That is a part view. I don't want a part view, I want the whole plan view. However, I do like the way how that's cut away, because you can see the members underneath when you're looking down. See how I've cut away. You don't have to copy my cutaway, probably can do it a little bit nicer than that, but that's looking down on those decking boards. So we cut the decking boards away and we can start to see some of the members underneath. See, there's a post over there starting to appear. That's a very common way of doing decks, by the way. Secondly, I've gone right against all my rules that I just showed you about 5-10 minutes ago, and I've used the most ugliest leaders ever known to man. Please do not do that. I've done it in a very sketchy way, because if I did it in a proper way, you guys would just copy it and get full marks, okay? So I've done it like that. You've got to disassemble all that. For example, these two notes, there's no reason why they couldn't line up nicely. Okay? That's just one example of lining up notes, which I've purposely not lined up for the assignment. You will need to think about some of these notes that I've got on here, because I don't mention anything about the timber, the tannalisation of the timber. I don't often mention the type of weld that we're going to use. I did say it's going to be welded, but we're going to, whole section on my notes is on welding. So you'll have to choose the type of weld and the symbol that you're going to use. And have a good look at the dimensions. Could you build it from my dimensions? You should be able to. But are there any extras that you could put on there just to make life a little bit easier for the person that's building it? There's a couple of different building terms in there. For example, whalers. I've never heard of these before I came to Unitec. A whaler is the cross member on the bridge going in this direction. This one here is called a packer. So that one goes in between these two here. Now the other thing is your line types. When you're drawing this, if you want to maximise your mark, make sure you get your line types right. If you look, go back to technical literacy, something's in behind, you dash it, because it's hidden. Remember those horrible little sketches you had to do for Ingrid? I made my degree students do the same thing as well. So you've got to just think about those things when you're drawing it. And it's not just good enough to put it on the right line type. Make sure it appears nicely in the drawing. Text type. It's different text types. I'll show you the different text types we're going to be using this time. The calculation is a lot easier. In other words, we're not dealing with meters anymore, we're drawing in millimeters. So if we want something at 1 to 50 to be 2 millimeters in layout space, all we do is multiply it by the scale. So 100 mils, 2 times 50, done. So you don't have to do that 1,000 conversion to meters. So in that case, it's easy. So therefore, it is 2 mils I want you to draw it. So most of the text is, not all of it. Those major titles there, longitudinal elevation, part plan view, they will be 4 mils. Okay, whatever the title block is, leave it. And underneath there where it says scale, you can make that 2 if you want to, or yes, I'd like you to make that 2. So 4 on top, 2 on the bottom. It's alright, it's in the assignment, it's written about 3 times in the assignment. Now the other thing is, you imagine a plan view across the top there to here, and you're trying to cram on minimum of say 10 notes. It's getting pretty busy. It's a very busy drawing, alright? So the biggest challenge here is making it all fit in without doing what some of you did in assignment 1, which is cut stuff off with the viewport. I know exactly why you did it, because it was 1 minute to go until Andon, and you quickly put it to the right scale so you didn't lose marks and passed it in, alright? It's almost as big an insult to the client by chopping stuff off as it is to not having the right scale. Because you don't want notes over here that you can't read with text coming into something over here. So my advice is when you come to assignment 4, and I know you're going to forget this, but do the same thing you did with your legend and your notes and everything. Set the viewport up, do it to a scale, go inside and do a rectangle. And then go into model space, and that's what you can't draw outside of. Absolutely nothing outside of, but delete it. A lot of people don't delete that at the end. And it looks really odd. So you end up with two lines around, just one line. So you understand what I'm talking about? You do a rectangle in model space, If you don't go outside that, then it's not going to go outside of your viewport. It's really tight, and it's hard to do, but that's a good tip. Notes. It's really easy to find 10 notes. I'll give you one. This drawing is in millimetres. There we are. You've got one already. So you're going to have to find 9 now. Okay. As we go through, we're going to be doing concrete, steel, and timber. This has got concrete, steel, and timber, which means you really only now, with 9 to go, have to pick 3 out of each section. It's not too hard to find a note out about concrete. You're going to see a truckload of them in that. Won't even give you one. All right. And as far as steel goes and timber goes, there's so many things you can put in the notes column. So to actually copy someone else's notes, I'll know immediately that someone hasn't actually been doing their own work. There's 63 pages of notes that we're going over in the next 3 days, so there's something in there for everybody to put onto the drawing. Right. Schedule and quantities. Oh, yes, schedule and quantities. So with your assignment, 5 marks is going to be for this piece here. That's going to be worth 5 marks of 15. This is assignment 3. We will go over that in the lab tonight or tomorrow. If for some reason you can't do the lab tonight, I won't guarantee you a seat, but I will allow this week students to come into the other lab and film it or take notes, okay, if there's a clash. Vice versa as well. If you can't make Thursday, you can come into the night's lab and do that. If the only warning with that is, if it's full, then I will have a class roll and I'll just go through it, and those that aren't there will have to vacate their seats. All right. It's important not only just for the assignment, but it's important for the test that you get your head around what I'm going to show you tonight. Tonight I'm not doing an abutment. I'm doing something that looks like an abutment. Your abutment looks like this. And I'm going to go over one in class that looks like that. So it's pretty close. Okay? So if you can get a head around what I'm doing tonight, there are a lot of similarities for working out the abutment. Not quite the same, but it's pretty close. Now these other pieces around here, okay, you're going to get the easiest mark you're ever going to get, half mark, sorry, for the concrete. You can work out the volume of the concrete in the abutment, half a mark. How about that? It's probably high school level 9, year 9. That's working out the volume for that. But then it gets harder. Timber, I want the member's schedule. This is an example only. I would suggest that timber could be reshuffled a little bit, but it's up to you. Steel, definitely. When we do steel next week in the lab, I'm going to go over an example. I might even do it in the lecture. And you'll find you'll probably need another couple of columns on this here. So be prepared to think about putting a couple of extra columns in there. Hardware, you can go as much as you want with that. This part here is worth 5 marks. The bulk of the marks is in the steel. I'll give you a clue. There is a bonus up here on one of the bars if you get it completely right. Most of the 5 marks for this is in the steel. You can go as far as you like with that. You can ring up Mitre 10 and get someone in there for 2 hours and bore them to tears about your assignment and get the exact description of every nut, bolt and everything on the job. Or you can do a basic hardware schedule. So I'm not giving you this drawing. You have to draw it up yourself. I'm giving you flexibility. You can use the table command on AutoCAD, but just be careful of that because I want the text types to still be 2. So in other words, if it's, sorry, the text height and layout space to be 2. The easiest way to do it, make this 1 to 50 and keep the same text height as on your other drawings. But you can do that whatever you like as long as it's 2 in layout. How do I check it? I just draw on top of this 2mm text, and if it's the same height, I'm happy. Alright? Yeah, so this bar schedule we'll talk about as we're going through the notes. There are going to be a number of drawings that you'll produce. You'll produce this one, you'll produce a plan, and that will be assignment 3, and then you'll produce the other one that we just saw, as well as the 3D sketch drawing. So 4 drawings for this set of drawings. Okay? And in addition, this won't mean much to you now, but it will a little bit later on down the line. A 3D, wrong one, sorry, the abutment reinforcing. Okay, this is the abutment reinforcing drawing, but it's a sketch drawing. And what you've got to be really careful of is exactly what I'm doing now. Do not do this. Okay? I've done this drawing so that it gives you an idea of what bar mark to call each bar. These numbers here are bar marks. And it doesn't actually look like that. I will sketch that now for you, and you'll see the difference between the two. So, that bit there is what I'm sketching, and this is what it actually looks like. You have a bar coming round and down, like that, and you have another bar coming this way, like that. Right? So these two are basically on top of each other, and they're pushed as close to the edge as possible, depending on what the assignment asks for with cover. That bit there is called cover. This is concrete here. And this piece here from that edge to there is called cover. I'll leave that sketch on there for the duration of the lecture. So I just wanted to point out that even although it does that, they are not side by side, they're actually in behind each other like that. But if I drew them in behind each other, you wouldn't know what was going on. I've done that to be clear on what is going on. And I do that quite a bit. So, like for example here, these two bars here are behind each other as well. With reinforcing, it's a bit like Grandma when she used to do the stitching around the edges of things. You always put the stitching as close to the edge as you can. Okay, so some of you didn't watch your grandmother doing that. Oh, you did.
Oh no, sorry.
Yeah.
When we're showing it, do you want us to put those on top of each other and so it just
Yeah.
look like one line with
Yep. So there'll be good question. There'll be a P line going like this and stopping here, and there'll be another P line going like that, and one will be behind the other. So, yeah. Okay. The cover becomes really important because these bars are up against it, and the cover, you're trying to push the bars as close to the edge of the cover as possible. That's why I was talking about Grandma. You know how she would stitch a quilt or something and she'd go right around the outside edge really close? No, you don't know about your grandmother doing that. Okay, that was for maximum strength as well, because if she did it on the inside, it would just rip away on the outside, right? So it's the same with reinforcing. For maximum strength, we push it right close to the cover as we possibly can when we're doing all our calculations. So that's the first thing you need to remember, and when you draw it, exactly right, like that. So this drawing you'll be using when you're drawing your plan view of this abutment, okay? So just bear in mind you do also need to download that. Okay, so here's the actual assignment, and these are the drawings that I just showed you that I've left, and also there's an AutoCAD title block and a logo there as well. And I just wanted to point out that this is the sharp end of the course. To complete these assignments, I think I'm being very conservative, but 6 to 8 hours a week is what I'm estimating. I could probably do them in 3 or 4 hours, but I've been on AutoCAD for just under 30 years, so you guys, I'm sort of thinking maybe 6 to 8 hours a week is what you need to try and put aside for this. That won't get you an A, by the way. That'll get you a very just C minus. So I just needed to tell you that because I don't know what you've got on at the moment. Most of you got a lot of assignments on, but you'll need to get your big calendar and work out how you're going to do those 3 to 6. That's not including lectures or class time. Some of you may prove me wrong. Email me, tell me I'm telling you a load of crap, you did it all in half an hour. That's fine, okay? But I think to do well in this subject is you do have to put the extra hours in. And I realise you've all got other commitments as well, to be fair. And I said this to my group degree class, you don't have an exam in this subject, it's gone. Early November, you're gone. You don't have to see me again, you don't have to study for any more, you pass your last assignment and you do the test, gone. And that's why there's so much work. Every year I get a lot of complaints about the amount of work, but I can justify it by the fact that you don't have to study for an exam. I don't know what you do for an exam, 40 hours worth of work, 20 hours, I don't know what you put in for studying for an exam. I know I used to put a lot of work in because I could never remember anything. Can't remember them up to either. Okay, so the assignment 3, due on Sunday the 7th of October, 5 p.m. The first layout tab that you have to produce on an A3 size drawing is a plan of the abutment. Tonight I'm going to show you a plan of a water race and you'll see how we draw the reinforcing. Okay? It's not perfect, but it does show you how we draw reinforcing. I will give you that plan. It's an AutoCAD plan. You can use it, you can pinch bits off it, or you can just use it as an example. You were groomed last semester for this and you didn't know it. Psychologically, we were grooming you for drawing reinforcing. Subliminally, exactly. Yeah. You didn't know it. And don't blame me, blame Ingrid. Don't tell her that. She told you that with reinforcing we draw those circles with donuts.
Yeah.
That's what I want. Okay. She told you the minimum bend for reinforcing was 2.5 times the diameter of the bar. That's what I want you to draw. May not ever tell you that again. She also may have, I can't remember the drawing because they've changed them every year, there was a lap involved. I will talk about laps and doing the calculation for laps. Laps are when you don't have enough, they can be vertical or they can be horizontal, depending on how long your bars are. If you don't have the length of the reinforcing bars not long enough, you lap it. Okay? If the assignment doesn't have a table on the lap is 32 times the diameter of the bar. So if the diameter of the bar is a 10 millimeter diameter bar, the lap will be 320. Okay? So a lap is 32 times the diameter of the bar. If there is a table, and there will be a table on the one we're doing tonight, you use whatever's on the table. So the first stage is drawing up the reinforcing schedule. The next stage is doing, the reinforcing plan. The next stage is the schedule. And the last stage is the quantities. So if you after this week, you're sitting there like a stunned mullet, which is a fish with its mouth wide open and you don't know what the hell's going on, try and start drawing the plan up. Draw a plan view of the abutment, offset for the cover, and then start trying to do the bars. We use P-lines when we draw the bars, which you should have known from last semester. We give them a thick as well. And once you're getting your head around the bars, start doing the calculations for the reinforcing schedule. Some of you may be able to start doing the quantities tables already. If you've had experience in life with timber, steel and that sort of thing, this might be a wee bit too easy for you. You might start doing that table straight away. A number of students in engineering are doing materials at the moment, which is good because a lot of this is running parallel at the same time with your materials class. So I do need to emphasise we're doing it with respect to drawings. I'm not going to start asking you how steel becomes mild steel in the process of doing that, okay? That's not what this class is about, but I do need a description put on the drawing, which will be from my notes. Everything should be taken from my notes. So after that, and as far as assignment 4 goes, we will be doing that drawing I showed you with the deck on it. Pretty much that drawing for 5 marks with your own notes around it. 5 marks for a 3D plan. And actually that drawing was worth 10 marks and 5 marks for the 3D plan. So there's quite a few marks involved in that assignment 4 drawing. With the 3D, I also offer a bonus mark if you want to take it further and start putting a lot of extra stuff on there, like the platform, the basketball courts, the wetlands, the actual ground as well, if you want to go further. And as I said, a word of warning, to some it's going to be boring, but to others it's going to be a good distraction from learning, I don't know, just for example, geotech. And you may end up spending too much time on my 3D drawing. It is only 5 marks, right? So there's some tips there for you, which will make more sense once we've done our 3 lectures. And there you'll see the text heights have been repeated a few times. 2mm and 4. I'm calling the minor headings underneath each of those sections and plans, okay? Look, if you're not sure, ask. It's not a trick. It's just that a lot of people didn't ask and they just guessed it for assignment 1 and 2. If you want to ask me what's the text height for the titles underneath, I will tell you. But I won't be telling you on the Sunday beforehand. Okay, so that's the assignment. We're now going to move on to the notes for this week. That should be available now. Can you see that on Moodle?
Yep.
assignment 4 ಇದೆ ಪ್ರಾಬ್ಲಮ್ ಬಂದಿದೆ ನವಂಬರ್ಗೆ ಇವತ್ತು ಇದ್ದಿದೆ ಇವಾಗ ನಾವು
Okay, so week 8 is what we're into. Somebody asked the hand-in time and date before.